Hi, my name's Chris, and this is my Robotics Lab 3 presentation. I'll start with TinyML, which we explored for over 3 weeks. TinyML is the practice of running machine learning modules directly on small, low-power devices like the Arduino Nano 33 BLE Sense. These models are designed to work without needing the internet, which is ideal for applications like gesture detection, sound recognition, and presence detection. On the first week, we worked with the microphone proximity sensor and the accelerometer. I was able to record and classify audios like the letters A and B, detect the proximity with hand gestures, and identify device orientation using the accelerometer. I also tested a pre-trained model that detected the presence of a person. On the second week, we moved on to vibration detection. I collected the accelerometer data while the board was idle and while shaking. I trained the binary model to classify the two states. After deploying the model, it could recognize the vibrations in real time with good accuracy. For the third week, we built a wake word detection system. I recorded audio samples of a custom word and trained the model to detect it. Once uploaded, the Arduino lit up an LED, and then the word was spoken. From this lab, I learned how real-world ML pipelines can be simplified and brought to microcontrollers. TinyML is useful in wearables, smart homes, and industrial monitoring. In the future, combining multiple sensors like audio and motion could lead to more reliable detection systems. Next is Edge Device, which focused on the object detection using YOLO V11 and the Jetson Nano. In week 1, I installed YOLO V11 and ran it on my laptop webcam, then created a custom dataset using RoboFlow with 50 images each of two objects, the phone and the wallet. After labeling and splitting the dataset, I trained it on Google Colab using T4 GPU, and the result was a .pt file that could be used in real-time detection. For week 2 and 3, we worked with the Jetson Nano, a small but powerful AI device, and I flashed the OS, installed the necessary libraries, and deployed the trained YOLO V11 model. The Jetson Nano successfully detected the custom objects using the onboard resources. We also integrated Line Notify, which sent a notification on the Line app whenever the target was detected. This showed how AI can trigger real-time communication without cloud servers. We even got access to a powerful NVIDIA A100 server and learned how to train our models remotely through Visual Studio Code using SSH. The lab showed how AI edge devices like the Jetson Nano are useful in scenarios where cloud access is limited to privacy and is a concern, like surveillance systems, autonomous drones, or factory robotics. The third topic was prompt engineering, where we learned how to communicate with generative AI models using natural language instructions. Prompt engineering is about crafting prompts and clearly telling AI what to do. We learned the components of a good prompt, like instruction, context, input data, and output format. We also explored techniques such as chain of thought, which guides AI to reason step by step, and a tree of thought, where the model explores multiple solution paths. We also tried interview pattern prompts and text-to-text transformations. In the lab exercise, our professor showed us an image, a peaceful mountain scene with a cabin, a lake, and a sunset. Our task is to write a prompt that could recreate that image using the AI model like DALL-E. My first attempt was simple, but after refining the word to include more visual and emotional details, the AI output got closer to the target image. From this lab, I learned how small changes in Word can drastically change the results. Prompt engineering is also a valuable skill in improving how we use AI, whether it's for creative content or tutoring or anonymous tools. Finally, we have computer vision, where we use C# and M2CV, a wrapper for OpenCV, to build our own vision applications. We started by capturing a live video using a webcam. Then we built a GUI to control the feed, adjust the camera parameters, and take snapshots. We displayed histograms to analyze brightness and contrast. And next, we applied thresholding to isolate objects using HSV filtering to detect colors. Later, we integrated facial detection, which I am currently using right now, using FARSCAD XML files. We also built an OCR system using tesseracts to extract text from images. In the final step, we compiled the face detection program into a standalone application. We also learned about different camera types using USB webcams, Gigi cameras, and camera links for extremely fast data transfer in manufacturing. This lab taught me how to build a full computer vision pipeline. for camera control to image processing and even application deployment. Real-world usages include manufacturing, inspection, and security systems. Future improvements could involve using deep learning for more accurate detection or real-time multi-camera setups. In conclusion, Robotics Lab 3 gave me valuable hands-on experience with real-world technologies, from deploying ML models on microcontrollers to edge devices, to guiding generative AI with language, and building custom computer vision tools from scratch. Thank you very much for listening. As you can see, this is our first assignment for the computer vision part. There's just a bunch of clicks. You click the button, it gets to 20, and then you can reset. Now for the second one is a simple calculator, where we choose our first two inputs, choose what application we're using, and then we press calculate, and it gives you the answer. For the next one, we created an application which can calculate the factorial of each number. So for example, the input is 10, and that's the factorial. For our next assignment was the integration of using a webcam into the computer vision applications. The main difference with this one is that you are able to view the colors in the different channels. So if you block it like that, the channels changes from black to white. You're also able to save this image into a specific file. This is when we are beginning to edit the external outputs. So as you can see, this is our camera here, and we can adjust the scroll wheel for a specific color, and this gives you the different processes. So I have the scroll wheel here, it gives you different black and white channels. If I go like that, black is completely white. This also enables you to save things. Now, this is another application where it is just another way to edit images. So for example, you are importing this file right here, and you have a lower and upper HSV. If they're both zeros, then they would output as red. So when I apply, it only shows the colors for red, and it shows you how many objects there are, and it tells you you can also choose a maximum area size. Now, this part is when we begin to use our knowledge from computer vision for facial detection. So as you can see, this is my face, and it creates a green box around where my face is. This is the text recognition application that we created. And you're given this using the specific XML file. It goes through all this data and chooses. So as you can see, it's not completely perfect. This is supposed to say Diego, but this is Dieg ND, and that's it.